So first off, I have a multiple choice question here. So half the points, are for multiple choice questions. The questions are more conceptual than you may be used to. They're longer questions than, like, say, even like the physics C test multiple choice questions aren't as just much reading and selecting both in the prompts and in the answers. So this question is actually about average, for AP question length. If you haven't seen practice questions like this, they like to do comparisons. So you see here, like, they say, okay, the diagram above shows a top view of a child of mass M and another platform of mass 5M. So they won't usually give you, like, 10 kilograms and 15 kilograms and stuff like that. They'll usually give you some kind of comparative value, whether that be M for mass or R for radius or D for distance or whatever. They'll give you some kind of comparative mass and then something that's 5M or half M or something like that. And so you still have to use those reasoning skills, but it's not in terms of concrete numbers as much as in terms of kind of a theoretical, single mass. And then so when we go through and we have to make sure that we read through these questions and analyze them, because a lot of times there are, I don't want to say trick questions, but they're looking for a specific type of understanding. So as we read through this, so it says, assume the platform rotates without friction. Which of the following describes an action by the child? Okay, so they like to deal with systems of objects and such. So it makes a big difference whether the action is by the child or by somebody standing next to the circular platform. It makes a big difference as to how the angular momentum is going to change in this case. And then it says that will result in an increase in the total angular momentum of the child platform system. So the child platform system includes the child and the platform, and that makes a big difference in how we answer the problem. If we're talking about increasing the child's angular momentum, increasing the platform's angular momentum, or increasing the angular momentum of both the child and the platform. And so what they want you to know in this case is that the child platform system, because the system includes both of those objects, right? That means that you would need to be outside of that system. So you would need to be a person standing beside the circular platform in order to change the momentum or the angular momentum of that system. The child could change its angular momentum, like the child could move out and gain angular momentum, and the platform would lose angular momentum, or vice versa. But the child cannot, by doing an action on the circular platform, change the angular momentum of the whole system. And so that's the kind of reasoning that we have to go through on these problems. And so you have to look for key terms like, oh, child platform system. Okay, the child is acting on the child platform system. That means that that means the angular momentum is going to be conserved. So as we read through our answers, we see, okay, D is none of the actions described will change the total angular momentum of the child platform system, because the child can't do anything. It would have to be an outside force of some kind. Okay, so that just kind of gives you an example of how we would go through and look at different problems, and we have to make sure that you understand all the concepts involved. And so we do a complete review of all of the concepts that are going to be on this year's AP Physics test.